Hi there. Now in this question we're asked to prove this identity 1 minus cos squared x all divided by cos x plus 1. And we've got to show that it's identical to 1 minus cosine x. So if you'd like to have a go at this one, haven't done so already, just give you a moment to pause the video, and when you come back I'll take you through the work solution, or you might want to fast forward just to see it quickly. Okay, welcome back then if you had a go. So this is quite a nice one. It shows off a new idea if you haven't seen it already. Now, which side do we take? Well, I said in a previous video that generally we look for the side that's got the most terms on. If that were the case, the right hand side has got two terms, the 1 and then the cosine x, whereas on the left hand side we've just got one term. But when we've got a fraction, it's most probably going to be easier to reduce this fraction just to a single line. So I'm going to take the left hand side on that basis. So I'd copy it in. We've got proof that it's 1 minus cosine squared x all divided by cosine x plus 1. And what's this going to be identical to? Well, I get a few ideas when I look at the right hand side here, which says 1 minus cosine x. 1 minus cosine squared x, this is quite common in identities to get what we call the difference of two squares. This factorizes. You should be familiar with the fact that a squared minus b squared, when you've got something squared minus something else squared, this is identical to a minus b multiplied with a plus b. The difference of two squares then. Watch out for this because it does occur a lot when you're doing identities, especially these types of identities. The difference of two squares then. So when we've got 1 minus cos squared x, this is the same as 1 minus cosine x multiplied with 1 plus cosine x. Obviously it doesn't matter whether you write 1 plus cosine x first, then 1 minus cosine x. It's just up to you which way round you do it. But difference of two squares then on the top when factorized gives us this. And then in the denominator here we've got cosine x plus 1. So we'll just put that in, cosine x plus 1. And clearly cosine x plus 1 is the same as 1 plus cosine x. You don't have to put this in brackets, but I've done that just so that you can see that we have now a common factor both on the top and the bottom, and they cancel. Okay, they go into one another once. And what are we left with? Well, it's identical to 1 minus cosine x, and that is what we had to prove. So a nice example just to illustrate this point here, the difference of two squares.